Koteshwar.
Thank you, Flora, to introducing to me. Thank you so much for giving the opportunity to present to my research, share with to everyone. So thank you for the Cergy Paris University and the Cergy BPI design. My topic is the presentation is on organic materials for photovoltaic applications. Out, outline of my presentation. So by sectors and energy sources. In this, I explained the renewable energy and non-renewable energy sources. Renewable energy is which type of we are using in human beings, and the second one is the photovoltaics and generation. Different developing the generation with three generations. What is the generation? Still now are developed. I will explain. And emerging photovoltaics now I have involved in the research field at dissensed solar cell and perovskite solar cells, and the applications of conclusion of perovskite solar cell and dissensed solar cells. Energy, mainly in energy is the ability to perform the work in the classic definition of energy. In energy, it broadly means a person is physical work to have and produce the changes between the two. And energy is based on sources divided into two types. One is the renewable energies and non-renewable energies. And they called as a conventional source of energy is called non-renewable energy sources. A non-conventional source of energy also called as the renewable energy sources. In renewable energy sources and plants and sun and water is the replenishment. Non-renewable is generally is the coal and minerals and soil. This is a non-renewable energy sources. If we are used it completely and we cannot recreate it. So, and energy source. Okay. Non-renewable energy sources mainly the nuclear energy. In nuclear energy are using in the uranium, plutonium, elements are using for generating the electricity from the using nuclear energy. Nowadays, human beings are using the nuclear energy, the electricity generation, and we are using the non-renewable energy sources. One of them also coal energy, using the coal energy and generating the electricity, and fossil fuel in sector. In these sectors are all oil and natural gases, and we are using this non-renewable energy sources and oil. We are using the generating and automobile and combination factories and sectors, and natural gases also we are using. So to overcome this non-renewable energy, so one day we can be up to 50 years up to we can use this non-renewable energy sources. Then after we cannot deplete, we cannot reach change and also not to overcome. So alternative to choose the renewable energy sources the development. We also are using the renewable energy source, renewable energies. It's like in the wind energy. Wind energy using the turbines in the mountains and the earth, using the turbines and the wind, using the wind energy to electrical energy nowadays. And geothermal energy is the heat generating from the earth, it heat to convert to the electrical energy. And hydro energy. In rare cases, hydro energy is also you are using and generating the electricity with the turbines in the inside of the flow of water, only the reservoirs and projects them. And another alternative energy is solar energy. Solar energy to and generating the electricity nowadays is going in the main sector in the developing the researchers generating the electricity, but with some limitations. Wind energy for few places we cannot the commercial and we cannot the all places. And geothermal energy also we cannot replace it to the all the places. So overcome the issue. And the hydro energy also only particular places in the flow of water and dams, the places are generating the electricity. But in the solar energy, we can place it anywhere. So we can develop with the researchers are developing the solar energy generating the electricity. mainly the global solution of coming energy of a crisis, coming days. We faced now are utilizing without electricity, we can't have life. So overcome. So already are using renewable energy sources, the wind energy, the thermal energy, and so but to overcome these issues, so better to generate the new technologies develop. So using the solar energy, your solar energy is the clean source of energy, is an unlimited source and no harmful to greenhouse gases and emissions. So environmentally is friendly. So you can use the solar energy technologies are developed. In this in photosynthesis, I think everybody knows the photosynthesis process. Photosynthesis process mainly the plants, green plants, take carbon dioxide and water, generating the making the food material and glucose and oxygen in the presence of sunlight and green plants, green pigment. Electrical conversion to into the sunlight light energy to the chemical energy. In the mainly in the light absorber is acting as a photosynthesis process is leaf, green pigment. In the light energy is converted to the chemical energy photosynthesis process. Based on that photosynthesis process, mimicking of this process, technologies are developed. That technologies, photovoltaics, how they are technologies developed, and I will explain the next slide. Mainly in photosynthesis process, light energy converted to the chemical energy. In the chlorophyll pigments, light absorber. In the function is CO2 converted to the O2 and the plants pigments making the food materials. Same this phenomena. And photovoltaics develop, light energy is converted to the electrical energy. In this light absorber we need. In photosynthesis process, light and absorb with the chlorophyll. But we create the light absorber, the artificial synthesis. So in this diagram explains the dicenter solar cells. In the color pigments, we can say that is the light absorber generating the electrical energy. Based on the photosynthesis process, they are developing sunlight, solar energy, solar panels, light absorbs, so the electron flow generating the electrical energy. Based on that, generations of solar cell in photovoltaics are three generations. First one is vapor-based silicon solar cells. Now commercially, nowadays is commercially the silicon solar cells. The first generation of silicon solar cell monocrystalline and includes the three polycrystalline and multi-junction. Monocrystalline is the different band gap materials are used. And another one generation thin films. In thin films, they are developed amorphous thin films and used the cadmium, tellurium metal, and copper, indium, gallium, selenium. In this generation, they developed the thin films. And after that, they reached the efficiency around 24-23%. But after that, we cannot do the commercialization, but some limitations are there. So overcome this, another generation developed, that is the emerging photovoltaics. Emerging photovoltaics includes quantum dots inside solar cells and organic photovoltaics, polymer hybrid solar cells and perovskite solar cells. Nowadays, it is the third generation emerging photovoltaics, increasing the efficiency and durability and low energy, easily synthesized and easily commercially we can plan to the commercialization. First one is the wafer-based silicon solar cell. The wafer-based silicon solar cell, first they developed the monocrystalline silicon. Monocrystalline silicon is reached the efficiency 25%. In this monocrystalline silicon is a durability highly efficient, durability is more. But main drawback is this is the very expensive. After the developed the polycrystalline silicon solar cells, these silicon solar cell compared to the monocrystalline silicon solar cell less efficiency. But it is here reached 25%. These polymer crystal silicon solar cells 23%. But compared to this one, less efficiency and less expensive. So another the researchers have developed again the multi-junction different solar cells. In these solar cells, reached the compared to the three monocrystalline and polycrystalline efficiency reached to 45, the highest efficiency. But it is limited the efficiency compared to this one more expensive. So overcome this issue. So again, the change in the second generation of solar cell. In first generation, monocrystalline and polycrystalline now commercial available. So commercial in our human being are using. So overcome these issues to develop the second generation. In second generation, mainly thin films, mainly the thin film based on second generation. In the Samarapus thin film silicon solar cells, flexible and large, and lifespan also very less lifespan. So and also expensive. So another generation is developed, the cadmium telluride. Cadmium telluride based silicon solar cell is compared to the amorphous thin film, it reached the high efficiency. But this is also very expensive and toxic chemicals are using cadmium telluride. So environmentally it's not good. So again, the copper, indium, gallium, selenium, silicon solars are developed. These solar cells and also using the more expensive and reached the compared to previous silicon solar cells, amorphous and cadmium reached high efficiency. But but in this case, if the expense is more, and also making the fabrication process also is very critical. So then after alternate to the generate third generation solar cell developed. In this third generation of solar cell, mainly in the four Dyson stage solar cells and organic photovoltaics, perovskite solar cells, and quantum dots. Dyson stage solar cell started in 1991. Reached to the around till now the 13% efficiency. In this photosynthesizer in the organic dye used. I will explain to the next slide and Dyson stage solar cell and briefly. And organic photovoltaics also started to last 15 years ago, but this is also started reached the efficiency 19%. These organic photovoltaics are used the small molecules and polymers. Another generation perovskite solar cells in this last 15 years they reached the around 26%. So efficiency is comparable to the in this generation perovskite solar cell is highest efficiency. Mainly these generations of low cost and easily commercializable and not traditional synthesis, easily synthesizing and flexibility anywhere you cannot fix it and color tunable. So mainly third generation, the first generation silicon solar cells in our commercial. So overcomes the silicon is the main disadvantages is very expensive and after the using the 25 years then after dismantlation environment polluted. So these three technologies developed to the overcome this single crystalline silicon solar cells in the three generations. The three types of Dyson style reach the efficiency 13% and increasing the efficiency type researchers going to the 14-15% and organic solar cell already reached the 15% and a quantum the 16% and perovskite the less time they reached the 26% of the efficiency. Till now, three generations of solar cells we are discussed. In NREL giving the official the efficiency, the recorded in National Renewable Energy Laboratory. Up to now, single crystal and silicon solar cells single crystalline silicon solar cells and multi-junction solar cells up to reach the 47%. Second generation of solar cells in fields around reach to the 23%, 23.6%. Emerging photovoltaics in licensed solar cells last 2 years reached to the only 13%. And perovskite solar cell started from the 2015, 14 to 15. Then reached the around officially they announced the 26.1 percentage. So nowadays, easily the commercializing getting researchers developing the and focus on the licensed solar cell and perovskite solar cells. Licensed solar cells. Licensed solar cell is also called as a gradual cell. Gradual is the inventor of licensed solar cell, 1991, he thought. And mainly in this, he used the organic dye from the this licensed solar cell is mimicking the photosynthesis process. In photosynthesis process, chlorophyll pigments and sunlight is generated. In photosynthesis, sunlight is converted to the chemical energy. Mainly, this phenomena is taken. The sunlight is converted to electrical energy. In photosynthesis, green pigment is the light absorber. In dye-sensitive solar cell, in light absorber is the organic artificial molecules, organic molecules. In this, yeah, he is used and developed the mainly theme of the developing this DSSC replace the silicon based solar cells. In mainly in the focus in a low cost and flexibility and environmental friendly. See, mainly the high efficiency and high stability is trying to the generating the new solar cells. Schematic structure of DSSC is DSC solar cell is containing the counter electrode and electrolyte and organic dye, TiO2 transparent conduction band TiO2. In this device architecture, the mechanism of DSSC. In this architecture, the sunlight is falling into the dye. Sunlight falling into the dye gets excited. The molecule is a ground state to excited state. After excited, the molecule in electron injection into the semiconductor. And the oxidized dye taking off electron from the redox couple. Taking off electron from the reduction. Now oxidized the dye is reduced. Electrolyte is reduced, oxidized. Then after electron moves from the load, the capture of the electron is taken. The electron move to the platinum counter electrode. After reaching the electron, is oxidized electrolyte taking off electron from the electrode is now neutralized. So again, the sunlight is fall and oxidized organic dye getting excited. Electron moves from ground state to excited state. It is a cyclic process. The DSCC is the main operating is the principle. Main technical challenges of DSSC. Technical challenge mainly in this up to solar cells focus on the efficiency and durability. So if we can develop in the recent solar cells, mainly different type of organic dyes. Up to there, we using the dyes and ruthenium dyes, and increasing the redox electrolyte, liquid electrolyte with gel polymers, and using the iodine cobalt electrolyte and to gap energy, band gap energy between the TiO to the band gap is a minimizing and charge transfer increase in the conductivity. Mainly the platinum counter electrode are using. This is very expensive. But to overcome this issue, so different type of small molecules are making the different electrodes with using so developed. And mainly in the molecular modeling and fabrication is minimizing. The fabrication process also will get in the critical. So overcome this issue, main technical challenges of the DSS. Present, the efficiency increases, but if your temperature rise, the increase in the temperature, that durability and less. and efficiency okay, efficiency reached. After some times, the temperature is increasing, that time durability is less. So overcome this issue to the main technical challenges. In dye-sensor solar cells, a mainly sensitizer is the light absorber. The light absorber in the case sensitizer is needs the good absorption. That molecule we can synthesize that molecule is the near IR region, and that molecule shows to the tightly binded with the conduction band of TiO. We need to the carboxylic acid or cyanoacrylic acid, the type of we need, and also that molecules sensitizer shows the suitable the homolum energy levels and easily synthesized, and that molecules is showing the thermal and electrophotochemically stable. So keep it in mind that for DSSC sensitizer is a design. Initial days, for DSSC application, they are using the ruthenium sensitizer. Ruthenium sensitizer in 719 and black dye they are used. The reached the efficiency around 11%. In 719 dye reached the 11.03 and black dye 11%. This efficiency is good, but some drawbacks is there. In this ruthenium complexes are used. This one is very expensive, and also ruthenium complexes absorption not near IR region. So absorption is a very less. UV visible region up to, and natural amount of ruthenium is very less. And this is the synthesis of not easy. This is the tedious synthesis. Stability is so poor. So overcome to this issue, replace the ruthenium sensitizers. So then after researchers move to the another molecules, different molecules you will study, synthesized. Then after ruthenium sensitizer, after that they used the small molecules. That is a metal-free organic sensitizer used for DSSC. Triphenylamine based molecules and fused the thiopine and alkyl chain increase by 1 to 3. It's a gradual co-work. The reported the molecule around reached the 10% of efficiency. Another group that reported that triphenylamine based molecules C217 achieved the efficiency 9.8. And remaining that triphenylamine based extended triphenylamine and benzothiazole and fused the fluorine molecule and phenyl cyanidic acid and with the co-sensitizers around reached the 13% efficiency. In these small molecules also show high efficiency, but problem in is durability is less. Reached the efficiency high, but instability, and also this absorption region near to near IR region not. So overcome this, another molecules are synthesized for application for DSS. If they introduced the phthalocyanine molecules. The phthalocyanine molecules that the PCH 001, it reached the efficiency 3.05. And some molecules for HBA, zinc, PC, cobalt, metal complexes, and cobalt PC molecule reached the, I'm explaining the very few molecules only. It's a macrocyclic ring and extended the conjugation system, and these molecules absorption reached the near IR region. Absorption we changed, absorption we increased for UV visible region to near IR region, but efficiency we they reached the efficiency very less to overcome. So again we can the inside the molecules. So changing the macrocyclic molecules, porphyrin. Porphyrin molecule compared to phthalocyanine. Phthalocyanine.
But you can avoid the different types because it's not a chemistry seminar. You know very well it gets just
Okay.
pass the message because it's not a
Okay, understand. Okay. Porphyrin sensitizer. The porphyrin sensitizer compared to the phthalocyanine, these molecular active positions are more, and beta position is there, extended the conjugation system, and U visible near to IR, near IR region. Then they synthesize these two molecules, and the reported these molecules are based on the fused porphyrin and bridged porphyrin molecules reached the less efficiency. Then after our molecule and based on that red gel, the reported the molecule SM315 reached the 13% efficiency. In this, my PhD work involved in this work. In my PhD, I did these molecules with my LG5, LG18, LG26, LG24. So we designed this based on porphyrin based molecule, achieved the efficiency at 10.4, 10.5, and 10.5 efficiency. Main advantage of DSS. In this DSS, I involved in the organic sensitizers, mainly in the expensive and roll to roll in the possible, and in this DSSC non-toxic earth abundant materials except to platinum and ruthenium can be lightweight and flexible to generating the DSSC modules. Mainly R&D challenges of DSSC in this low rate near IR absorption region, and they are using the redox couple iodine electrolyte, and low extension coefficient surface area and undesirable solid state. In future, using the goggles, we generating that electricity or using the mobile charging and also there maybe we are in future generating the electricity with using the goggles. DHSC mainly application in transparency and building integrated photovoltaics. We can implement in the windows and curtains and different colors and different type of this windows and glasses displays also we can implement the DSC modules, can generate the electricity, and also transport system in train and inside the bus with the normal light also generating the electricity. This type of module we can expect in future. Another one emerging photovoltaic technologies is our perovskite solar cell. They introduced. They started in 2015, but till now they reached the 26.1 efficiency. In this solar cell, is mainly the perovskite structure. Is it the ABXD crystal structure? It absorbs the material. Is the mimicking of DSSC. In DSSC, light absorber is the organic dye, but in this perovskite material, perovskite solar cell, perovskite is the light absorber. Changing between DSSC and perovskite, DSSC electrolyte, you are using the iodine electrolyte. In perovskite, using the old transport material. Mainly the perovskite are using the methyl ammonium lead triode. The perovskite are using. The device architecture of perovskite solar cell in this regular NIP and inverted the NIP and architecture mesoporous. Is mainly in this T performs electron transport layer and hole transport layer. Mainly in the electron transport is the collector the transport the electrons. In the whole transport layer, main key role play in collect the transport the holes. Mechanism of perovskite solar cells, mimicking a DSSC, mainly in DSSC also same. In the replace of DSSC organic sensitizer, in perovskite solar cell is the perovskite. In DSSC using the iodine electrolyte, in perovskite solar cell in the whole transport material. In this photo excitation of the dye, photo excitation of the perovskite, electron move from the ground state to the excited state. After excited state, the electron is conduction transferred to the conduction band TiO2 and reach to the LO. After the electron move to the ground state, excited state, hole is transformed to the hole transport material. After the electron move to the counter electrode, the hole transport material capturing the electron from the counter electrode. So regeneration of this process is done. So hole is transferred from the perovskite to hole electrolyte. Mainly this component of perovskite Metal electrode are using the gold, and gold transport material usually are using the spirometry, and absorber layer is the methyl ammonium lead iodide, and electron transport layer are using the here TiO2. Perovskite solar my research work on the all transport material. Whole transport material is pyrometer usually are using the whole transport materials, and also polymers or molecules also are using to this is pyrometer is having traditional synthesis and overcome you cannot do the commercialization is very expensive. In future we can do the commercialization of perovskite solar cell, overcome this issue, replace the perovskite solar cell. Mainly the need the whole transfer material that molecules need the thermal stability and allow hydrophobic nature and easily synthesizing, charging carrier mobility easy, and also the film forming capacity in the device fabrication to be flexible. So alternate to the choose the better the spirometry of the molecules overcome this issue. Synthesize these molecules new. These molecules are reported spirometer basis spiromolecules using the fluorine, but reached the 22% of efficiency compared to spirometered less. But after that, small molecules are taken the whole transport material and reached the efficiency around 16%. And the small molecules also trying to the replace the spirometered molecules. And same in raisins and solar cells also introduced in the porphyrin molecules, and also what are permitted as the porphyrin molecules also introduced. They reached the efficiency 15% added in the whole transfer material. And previously they reported that molecule around 16% is the porphyrin based molecules choosing the different centers A2 B2 porphyrins, and it is a different increase in the alkyl chains which are the highest efficiency. These molecules are 15%. After that, my research in my group and my PhD work and involved in the perovskite solar cell, mainly synthesize the whole transport materials. We synthesized with the donor 5 donor concept based phenothiazine molecules. We reached the highest different metal centers, highest efficiency in our laboratory, that 12.88. In my PhD, I did the 3 molecules and for whole transport materials for perovskite solar cells. These molecules show the efficiency, highest efficiency in copper molecule, shows the 12.44 efficiency. Without metal center, 9 point. This zinc metal is around 11% efficiency. The donor 5 donor in this triphenyl imidazole based molecules. In the summary of directions of research, mainly DSSC or perovskite solar cells. Mainly this is the transparent and flexibility, easy weight and stability, not too harmful to the environmental impact, and low cost, easily commercialization. Based on that, research is going in the efficiency. Silicon solar reached the 27%. But these molecules, these DSS or perovskites, improving the efficiency and different easily commercialization, low cost materials are using. And commercialization, they are developed the researchers 3G solar and Israel, their rooftop application and rooftop application at Toyota, that then installed in the DSS and perovskite solar cells. And this is easily flexible. In future, in this type of in the bag, we are using that solar cells. Easily we can laptop charging or mobile charging. So we can expect this type of modules in future. In the using the DSS here perovskite. So researchers are moving this are easily and simplifying and reducing the cost and getting easy commercialization. Thank you.
Thank you very much, Koteshwar, for this